Hello students, so today we are going to learn about Rutherford model. This model is also known as planetary model or solar model. So we will see about this model, how this model came into existence and why this model was needed at that time. So before Rutherford model there was one more model that is called watermelon or plum pudding model. I think you know about this model, watermelon or plum pudding model. So this model got discarded or got rejected very soon after it came, and this model was given by Sir J.J. Thomson, and it was a hypothetical model. Hypothetical model means it didn't have any scientific proof, so it was just a hypothetical model. So what he thought that, and he explained the atomic structure, like structure of atom is like plum pudding or like a watermelon, and as the seeds of watermelon are embedded inside the red matter, similarly the electrons are embedded in the atom. Negatively charged particle electrons are embedded in atom like the seeds are embedded in the watermelon, and whole positive charge of the atom that is distributed in the whole atom like the red matter is distributed in the watermelon. So all the red matter like distributed in the watermelon, similarly whole positive charge of the atom is distributed in the atom. So this model didn't have any scientific proof or mathematical proof, and this model could not explain any of the important properties of atom. So this model got discarded very soon. It came into existence. So after this model, the next model which came, that was your Rutherford model. So this model was a quite better model than Rutherford model, because this model was the first model which was based on a scientific experiment. So this was first experiment based model. First experiment based model. And what was that experiment? That experiment is very famous experiment that we call alpha scattering experiment. So this is called alpha scattering, or there is one more name for this experiment, alpha scattering, or that is also called helium nucleus. Helium nucleus impingement experiment. Okay, so why this is called helium nucleus? Because helium nucleus is nothing but it is alpha particle. So what is alpha particle? Alpha particle is the helium nucleus. Helium nucleus is made up of 2 proton and 2 neutrons, and so it will have plus 2 units of charge because of 2 protons. So alpha particle is the same thing. Alpha particle is a particle which contains 2 protons and 2 neutrons. So it has 2 positive charges. This is alpha particle, and the same thing is helium nucleus. Okay, so this experiment we were talking about, alpha scattering or helium nucleus impingement experiment. This was performed by Ernest Rutherford. And what did he do in this experiment? He took a very thin gold foil. So how thin this gold foil was? This was 1000 atom thick gold foil. So I have made here the gold foil, but this is not 1000 atom thick. This is for just a representation purpose I have taken here. I have taken just 2 layers of atoms here. So what did he do in this experiment? He projected alpha particles towards this gold foil. So I have shown some lines here. So some lines are in blue color, some are in pink color, and very few, like here this is in white color. So what was the observation in this experiment? Every experiment has some observation. So this experiment has, first observation was most of the alpha particles pass straight through the foil. Okay, and second observation was few alpha particles get deviated at angles greater than 90 degree, which you can see here, like this alpha particle, these 2 alpha particles are getting deviated at angles larger than 90 degree because their original path was this way and they got deviated more than at 90 degree angle. So this was second observation, and third observation was very few alpha particle. How few? 1 mm 20,000 alpha particles that get reflected back and retrace their original path. So you can see here I have drawn this white line here. So this white line is saying that the alpha particle going towards the gold foil that is getting reflected back on its path. So this kind of alpha particles were very few. They were 1 among 20,000. So these 3 were the observations of this experiment, and on the basis of these 3 observations, Rutherford made some inferences. So on the basis of first observation, like most of the alpha particles are getting straight through the foil. The observation of that experiment was that most of the atomic space is empty. So this was the first inference based on the first observation. Similarly, on the basis of second observation, Rutherford made the second inference, and it was that there is a small positive charge at the center of atom. Why small? Because there were very few particles which were getting deviated at angles 90 greater than 90 degree. That means there is some positive charge at the center of the atom. Why positive charge? Because alpha particle itself has positive charge, and if there will already be a positive charge, those alpha particles will get repelled by that positively charged center. So there is a small positive charge at the center of atom, and Rutherford called this center of atom, he gave it a name, he called it nucleus. So sometimes if someone asks you who discovered nucleus, actually it was Rutherford who discovered the nucleus. Okay, so this second inference, that was based on the second observation. Similarly, the third inference was because third observation says that very few alpha particles get reflected back on and retrace their path. That means none of the alpha particle was able to penetrate through the nucleus. It got reflected back on its path. So the conclusion made on this observation was that nucleus is very small and highly dense. Very small because this kind of particles were very few in number, 1 among 20,000. So that means the nucleus is very small, and this is highly dense because none of the alpha particle could get penetrate through the nucleus. So these three were the observations, and based on those three observations, he made three inferences. Okay, so now let's come to the Rutherford model, what model he proposed on the basis of this experiment. So the model he explained on the basis of this alpha scattering experiment or helium nucleus impingement experiment was atom is spherical and most of the atomic space is empty. Second point of the model was whole positive charge and almost whole mass of the atom is concentrated in a very small nucleus. And third point of the model is negatively charged electrons. It was already known in advance that electrons have negative charge and protons are positive charge, but that time proton were not discovered. So it was that positive charge of the whole atom was concentrated at the nucleus. So negatively charged electrons, he proposed that negatively charged electrons revolve around the nucleus in circular orbits like planets revolve around the sun. So that's why his model, Rutherford's model, is also known as solar model or planetary model. So this model was quite better than the previous model given by J.J. Thomson, like watermelon or plum pudding model, but still it had some drawbacks. What were drawbacks? First thing was it could not explain the atomic stability. At that time there was a Max Planck's quantum theory which says that whenever a charged particle is in accelerated motion, it will radiate energy. And in circular motion, you know that if any particle is performing circular motion, then there will always be a acceleration that we call centripetal acceleration. So if there is electron which is revolving around the nucleus, so there is acceleration, centripetal acceleration, and because of that acceleration, this electron will keep on emitting energy. So if it will keep on emitting energy, the orbit of electron will keep on getting smaller, and finally it should get fallen into the nucleus, and so atom will get destroyed because when negatively charged electrons will meet with the positively charged nucleus, the two will neutralize each other and the atom will get destroyed. But this doesn't happen actually. So that means Rutherford's model could not explain the atomic stability. Second thing was there was a atomic spectrum. So we will explain that atomic spectrum thing in another video. But yeah, there is something characteristic spectral line when you put these atoms in a gas tube and you provide energy from outside to them, and when they those electrons get to the higher energy orbits, and when they get back to the original levels, they emit energy in the form of lines. So we get spectral lines. But these spectral lines, when you put these spectral lines into electric field or magnetic field, these lines get divided into fine lines. So this experiment he could not explain. Like when spectral lines get splitted in fine lines in electric field, this is called Stark effect. This is called Stark effect, and when these spectral lines get divided into fine spectral lines in magnetic field, then this effect is called G-Man effect. G-Man effect. Okay, so he could not explain two of these primary things, and in later we will also see that his model was wrong because he was trying to predict the position and momentum of electron at the same time, which was not possible, that given by Heisenberg uncertainty principle in quite after many years. So that drawback is also present, but majorly there were two drawbacks which Rutherford model could not explain. So I hope you understood this Rutherford model and you enjoyed this video. If you are liking my videos, you can like my videos and subscribe my channel and share these videos with your friends also. So thank you very much. Take care and bye bye.